So let's use the step-by-step process laid out in the previous video. Let f of x equal x squared minus 3x plus 10. We're going to find all of the stationary points, that's synonymous with critical points, and classify them. We're going to classify whether they're a max, a min, or a saddle point. Step 1, we're going to determine the first derivative f prime of x. So I'm going to take my f of x function, and I'm going to take its first derivative. So f prime of x is going to be equal to the derivative of x squared is 2x, and the derivative of minus 3x is minus 3, and then the derivative of 10 is 0, so we're pretty much done. Step 1 is done. I'm now going to do step 2. Step 2, I'm going to set f prime of x equal to 0 and solve for the x values. So I'm going to set this derivative to be equal to 0, and I'm going to solve for x. So I'm going to move this 3 over to the other side of the equation. 2x is equal to 3. I'm going to divide both sides by 2. And I get x is equal to 3 halves or 1.5. So now I know where the critical x value is. This is what we're going to refer to as the critical x value. Step 2 is done. Step 3. I'm going to determine the associated f of x value for the critical x value. That's just the vertical axis value to complete the coordinate. So I'm going to take my original equation right here, and I'm going to substitute this critical x value into it. So I have f of x is equal to, my critical x value is 1.5. So I'm going to square that, minus 3 times my critical x value of 1.5 plus 10. And that is going to give me 7.75. So now I have located the exact coordinate for my critical point. It is at 1.5, 7.75. That is my critical point. I have found it. Next thing I need to do is to classify it. Is it a max, a min, or a saddle point? So the next thing I'm going to do is I'm going to determine the second derivative. This is where the classification process starts. So f double prime of x is equal to what? Now that's going to be the derivative of this function up here, our first derivative. So the derivative of 2x is 2. And the derivative of minus 3 is 0. So our second derivative is positive 2. So now I have determined the second derivative. Now the next thing I would do is I would do the second derivative test. This is going to be calculating f prime of x for all the critical values. So I'm going to take my f prime of x for x is equal to 1.5 for the critical value. Now this is a special situation because f of x is equal to 2 for all x values. So we know that f double prime of x is equal to 0 at x is equal to 1.5, as well as for all other x values. So what does this second derivative test tell us? Well, it tells us the shape of our function. If the second derivative is negative, we're dealing with a function that is concave down, in which case we're dealing with a maximum. If the second derivative is positive, we're dealing with this function that's concave up, in which case we're looking at a minimum. Of course, if it's 0, we don't quite have an answer yet, and we're going to have to move on to step 6. So in this case, f double prime of x is equal to 2. This value is greater than 0. So we can see here that it's a minimum. And I like to give you this visual aid to be able to help us with that. What it means is that we have a concave up shape when our second derivative is positive. It's got a little happy face. When the second derivative is positive, we get a concave up shape, meaning where the slope was 0 is going to be at a minimum. So now step 5 is complete. Because step 5 was conclusive, because we were able to determine that it was a minimum, we don't need to do step 6. Step 6 only applies if step 5 is inconclusive. So we're done step 6 as well by default. We're really done our classification of our critical point. So we know that we have a minimum at 1.5, 7.75. That is our coordinate. And this is finding and classifying our critical point or our stationary point. Now let's look at what this looks like in a graph. Our graph looks like this. What we have is a concave up shape, forms that concave up shape, which we aren't surprised by because of that second derivative test, and that when x is equal to 1.5 and y is equal to 7.75, or I should say f of x is equal to 7.75, we have a minimum value for our curve. Now we have a couple more examples to do to drive this point home.